the Gold Team. And today I'm going to go over our frequency and body plot experiments with the pressure control spray booth system. Other members of the group are Clay Weiser and David Doss. Okay, first of all, I'll go over the system description, our previous work, and next will be current work, all work since the last presentation, and then that will include the frequency and body plot, and then I'll go over summary. Okay, here I got the block diagram and the schematic on the same slide here. The input variable was the percent power into the system, and the output is the pressure in centimeters of water. And right here is the fan, and power is set up there, percentage of power. Flows air through the ductwork, supplying the three booths here. And with our experiments, both the dampers are open. And desired output is 18 to 30 centimeters of water. Okay, here, this is it's our steady-state operating pressure curve, and it ended up being an average 0.58 input percent. And with our step response, the lines in black here and the arrows point out to how we found each measurement here. The tau average for all experiments was 0.6 seconds. T naught, 0.1 seconds. And the gain, 0.6 centimeters of water per percent. Okay, now with the new material, here's the modeling of the step response. And we got the model of the input to fit up just exactly, well, on most of them, almost exactly on top of the experimental input. And then with the output, of course, the modeling is a smooth line, and that we fit up as best we could with the output of the experiment. They all fit pretty good on there. Now here, I wanted to go ahead and put in a mathematical model of the frequency experiments, and into the system is a percent as a sine function, and then in the system, the Laplace of the sine function is multiplied by the FOPT formula, and then with the output, it gives us the amplitude ratio times the phase angle. Okay? And then, of course, again, with both dampers open, and the output range is 18 to 30% centimeters of water. Okay, and for the frequency inputs, two members did the regular experiment with 60 to 80% power, with a frequency range of 0.1 to 2 hertz. And then the relay feedback was done with 60 to 80% power. Okay, this is just a screenshot of how we found those measurements there of the peak-to-peak input right here, and then peak input to the peak output, and of course here's the delta C and delta M. Okay, and the equations used for those for the experimental data was amplitude ratio, delta C over delta M, and the phase shift was the difference in the sine peaks over the period of the sine times 360. one of our experiments there. And two of the members did all the found the amplitude ratio, phase angle, and uncertainties of those frequencies at 60 and 80% power. And then with this, we developed our Bodie plot. And here, I have on this slide, well, first of all, this blue is 68% power, red is 60% power, and the ultimate control again was found using the phase angle diagram here. We looked over at 180 degrees, and then drew a line, vertical line straight up, and then where it meets the amplitude ratio lines there. We found 2 and 3% centimeters of water for the two powers there. And then where that line meets at the top with the frequency axis, that's the ultimate frequency, which found to be 2 cycles per second. And then the gain found to be 0.7 centimeters of water per percent. And all these we put in error bars there with uncertainties. We found greater uncertainties at the higher frequencies. Okay, this is the relay feedback experiment. And the tau and dead time is found similarly to the how the peak to peak and the period is found with the other experiments. Okay, with the modeling equations, the ultimate control of gain is found with 4 times delta m divided by pi times delta c. Then the transfer functions, amplitude ratio is k over square root of 1 plus omega squared times tau squared, and phase angle, negative omega times t naught plus inverse tangent of negative omega times tau. And then with the modeling, experimental, and relay feedback, we wanted to compare all those as far as dead time, time constant, and gain. And once we could really see how they really vary all over with this plot right here. And finally, with the modeling of the Bodie plot, the experimental is just the markers, the blue markers there. And then the model is a straight curved line. And again, it's smooth, unlike the experimental. It's lined up a lot better with the amplitude ratio and the phase angle. A few points there, phase angle a bit further away there. And we found the ultimate frequency to be 3 cycles per second. The gain, same as with the experimental, 0.7 centimeters of water per percent. Ultimate control gain, 3% over centimeters of water. In summary, with the step response, was a very good fit for all the experiments. The Bodie plot comparison, we found the gain to be approximately 0.7 centimeters of water per percent. There's quite a bit of variation in dead time and tau, time constants. And then the ultimate control gain was approximately 3% centimeters per water. And the ultimate frequency, that is 3 hertz.